Good morning, everybody. My name is Ted, and this is the unofficial Mac platform layer for Handmade Hero, and we are making some serious progress as always. We're actually on day 25, which is kind of ridiculous. I knew it would come to this. I knew that we would actually get this. This is pretty darn close to the end. This may actually be the end, at least as far as this is concerned. Basically. Well, even right now, if you wanted to, you would be able to follow along with Casey's Handmade Hero pretty far, actually. There's maybe a few places kind of along the series where you may need to kind of revamp the platform layer a little bit, but you would be able to follow along pretty well. And actually, it isn't so much about doing exactly what's in this series, like what I show you how to do. And you'll notice, kind of as I do it, I still am kind of having to remember and go back because I don't really do this sort of thing too frequently. Um, you will discover that through this process, you'll actually become a much better C programmer. And that experience that you gain will pretty much mean you don't no longer need the training wheels. Like you can do your own kind of platform layer and you'll be able to kind of follow along with whatever parts of the show that you want to. For me, I sort of pushed all the way up to day 50, but then I got that I sort of wanted to like work on my own projects based on kind of what I had learned, and so I started to make my own game with the platform layer kind of as a basis. And so I sort of suspect that after you get to about where I got, you'll maybe make that decision, or maybe because usually the reason that you want to do something like this is because you have some project of your own that you want to work on and you want to do things kind of from scratch, kind of as a baseline. And so that's sort of the direction that I went. On my project, I kind of went to GPU rendering a lot faster than on Casey's project. And it's just because Casey's project is way more instructional in nature. He wants to show you what a software renderer actually does. And it's super useful. It's just I kind of doing a mix of following the series and kind of working on my own project in my spare time. So, with that said, kind of the last thing that we're doing right now is setting it up so that we can do kind of this replay sort of thing. So I'll show you kind of what I have going right now, and I showed this in the last video too. But if you take a look on my platformer game prototype, so I got my character right, and I've got my controller here, and I'm moving him along. And by the way, this renders at 60 frames now. Pretty happy about that because I moved all the rendering to GPU. I press L, and now it's actually going to record sort of the stuff that's going on in the game. This is some kind of mechanic that I made. Then I press L again, and it's going to play that back, right? And so that's kind of a cool little feature to have in an internal build. And then I think it'll start over again. And then if I press L, it'll stop. So these are cool things, and that's obviously really useful. When you're working on a game project, you want to be able to kind of do this sort of live looped code editing thing. But in order to do that, there's a few things we got to kind of set up. So kind of high level picture of what we're doing. We're going to use a memory mapped file for this. So what we're going to do is we're actually going to have this concept of a single location that sort of like represents the memory for the replay and for all of the inputs that we're taking. So there's two things that we want to take in order to be able to do this kind of recording. The first thing that we want is we want sort of like a snapshot of the memory at the point that the recording started. And the next thing that we want is a way to sort of stream inputs from the game controller or also from the keyboard as a person's playing. So as a person's playing, we're actually going to stream their input, their button presses and whatnot, into this memory mapped file. And then what's going to happen is when we stop the live loop code editing, we're actually just going to hop back to the beginning of that input, and we're gonna actually swap out the we're gonna put back the old memory block that we saved when we actually started recording. And again, what I kind of want to emphasize, and what Casey also emphasizes, you know, Casey's explanation is going to be much better than mine. But the reason that we can even do any of this is because we've decided that up front we're actually going to allocate all of the game's memory, right? So the only reason we can do any of this is because we've decided that the memory for the game state is just going to be this like big block that we allocate up front. Now what that allows us to do is we can take this permanent storage part right here, this like 64 megabytes or whatever. So that's what we defined here as our permanent storage is 64 megabytes. We can take that and we can actually just like we can wholesale save the permanent storage to this memory map file. Now in mine, I actually didn't include any of the transient storage just because I found it to be kind of slow in my system. So, it's up to you. I think sort of, a future kind of more robust implementation of this would use all of the memory, but I figured I'd only work on the permanent storage. And that's actually more useful for the beginning parts of following the series just because, he doesn't really use transient storage for a while, and so it's kind of like, probably not super important. But, up to you if you want to use kind of both the permanent storage and the transient storage. But in any case, because we've like wholesale straight up allocated all the memory up front, we have this kind of amazing ability where we can just like save the whole block of memory at the time that we started doing the looped live code editing, and then we record inputs, right? And then at the very end, we just, if we want to like play that loop over again, we just reload the memory. Like we've got the whole memory, so we can do that kind of thing. It's pretty cool, and only really the sort of thing that you can do when you have this like low level sort of access. It gets to be more challenging when you don't have direct access to memory in this way. So take a sip of my coffee. So the first thing that we really need to do if we want to kind of get set up with any of this, I think it's probably a good idea to start kind of introducing, because I have this in the platform layer, sort of this concept of a Mac state. And so I'm just going to go and grab that from the work that I've been doing. But basically the idea with this Mac state is it's kind of like one sort of place that just represents, I like it, and it's kind of in some of the other platform layers as well. It just represents many of the things that we are, how shall I put it? Many things that are just sort of like Mac platform specific. So I don't know, maybe just make a note here, like, this is Mac platform specific state, and it's really just kind of, this is almost like game state, right? So we've defined that struct, the game state, and that is something that's really only in the game's platform, the game library itself. So you've got game state, you got Mac state. This is just stuff that is like Mac specific. And so in this case, we've got sort of like a pointer to the game's memory block, which is going to be really useful because we want to be able to like swap that in and out depending on what we're doing to replay. So a lot of this is in order to support this replay feature, and we've got the file handle for replaying, and so we're actually going to use that file handle. This is going to map to it's going to go to our memory map file that we're about to set up, and what that'll do is it'll allow us to kind of skip around that file and be able to start playing back inputs from the controller or from the file, or also record new inputs from the controller. And then we just have this, the file name, like where that is. So we want to probably hang on to that. And then the replay memory block, that's just going to be the permanent storage from the game memory block. that we end up loading at the start of a replay, and that we also end up saving. So that's actually going to be really useful for having kind of a defined start point for when we actually do the replay. And this is just the path to the actual. I lifted this up into this struct because it turned out we were kind of using it in quite a few places, and it sort of makes sense to be kind of in this struct. But this is just the path for the executable itself. So we kind of keep using this a lot, and so it sort of made sense. And then we've got, in order to do this recording and playback, so Casey's version, his first version actually does, he's got like several replay buffers. So, he has kind of this like pretty high powered version that lets you do like, you can save like 5 of these at the same time or whatever. I didn't find that super useful right away, and I kind of like prefer the more a more simplified approach. At least it'll be kind of easier to get through. And if you want to then set up more than one replay buffer and kind of do your own system, I think you would have the foundation to move from this to something else. But it's just kind of a nice. I just kind of want to keep it simple just for this first pass, and you don't really need to have like 5 different replay buffers or like all this kind of fanciness just to be able to follow along with Handmade Hero. You really only need one. So I just kind of I prefer the minimalist approach. So that's kind of what we're doing. We're just going to have a single kind of replay buffer that we're going to use, and then I don't know why we have this resources directory. I think I use that in a separate project, but maybe we'll use it, maybe we won't. Probably doesn't matter. Either way, now that we've kind of decided to use this concept of a max state, that means that we actually need to change quite a few things. First of all, some kind of cleanup that I wanted to do. One of them was I needed to lift this into the actual header file, so we're going to do that. And that's a pretty simple change, but we'll just do that. So now we've got this Mac max file name size. We got this concept of a Mac app path. I'm actually going to put this right here before this Mac state struct. I think that makes more sense. So we got that. Yeah, so, all right, kind of moving along. Now this is going to break a bunch of stuff, and that's okay. So kind of one of the things that it's going to break is probably, well, let's see. So what I want to do is we want to set up this yeah. So I think like right here, kind of before we set up the memory, this is where we want to set up the max state. So we're just going to call it max state, and all that is just a struct, right? And there's a few things that we're going to want to get set up with, kind of default initialize for it. So is recording and is playing back, those should be false by default. So we're just going to do that. And then is playing back, and that's going to be false. So we got that, and then we also probably need to set up this concept of a path. So I know that we use this thing, this Mac app path. So what I want to do is I actually want to pull that up to the top of the main function, near, like a little bit closer to max state. It just kind of makes more sense that it's there, because this path now we're not gonna just have this path kind of hanging out there as just like its own entity. What we're actually going to do is we're going to like make the path a part of max state, so that kind of path gets passed, can be passed with max state. It'll be useful for the most part. So we got this path, and then what we're going to do is we're going to say, okay, well, max state dot path equals path. Okay, and then what we want to do is just pass that max state dot path. And so what that's doing, remember this Mac build build app file path, right? So what does this do? We kind of went over this in the other sort of videos, but basically what it does is it gets us this ns get executable path. So what that does is it figures out where our game is located on our Macintosh personal computer, and then it tells us where exactly the one past the file name / or whatever. So it gives us like some context on where we are in our file path. So we can then use that to build a bunch of other paths that depend on it. So that's sort of the thinking there, is like, we have we're going to have a bunch of paths that depend on this, where the actual executable is. And the big reason that we have that is because the Mac is pretty darn restrictive about accessing files outside of what's called kind of like the sandbox. So applications typically tend to be inside of a sandbox of some kind, and the operating system is just such that if you kind of touch like file I/O outside of there without the right permissions, your app usually just crashes. So when we set up this replay buffer, just like a lot of the other things that we've set up, we need to have that file actually inside of the application bundle itself. Otherwise, you pretty much just get an instant crash like right away. So we don't want that. Anyway, and then now we've got this path thing, so we just need to make sure that whatever path is used, we pass maxstate.path instead, right? And so we built the file name path for the game library bundle. Remember that? So now we're using maxstate.path. Okay, great. Let's see. Okay, and then that's using that. Yeah, okay, so that's I think that's like kosher now. So, okay, just going back down, and let's see. So I just want to, just do a build and see kind of where we are in terms of if there's any compile problems. Okay, so nothing there. That's very good. Okay, so we got our max state, we got our max path. These are all good things. Like I said, this is just kind of like cleanup that we have to do before we get going. So the other things that we want to set up, we want to know, we need to set up this game memory block and this permanent storage size, right? So what that does is it lets us know, where is a pointer to where that game to where that memory block starts. So the important thing there is we've got this kind of game memory concept started, and then it isn't until right around here, right, right after we set up the memory that we use that. So what we'll do is we'll just say, maxstate.gameMemoryBlock equals game memory dot permanent storage. Yeah, it's just permanent storage. And so this game memory block. Remember, at least for this version, we're just gonna start with the permanent storage. We're not gonna do more than that for now. Later on, you can probably do more with the transient storage, just kind of depending on your development machine and how fast it is, and sort of you can tweak it to your leisure. Again, I kind of wanted to go with something that would be sort of simple and fast. And then the permanent storage size is just going to be the size of the game memory. Yeah, game memory dot permanent storage size, and that should be fine. All right, so those are all things we kind of need to set up. So now right here is sort of where we want to do this setting up the actual setting up the memory map file, and got some code for that. Basically what we want to do is we want to set up we want to just open up a file handle to that. So and we'll kind of walk through some of this stuff. But what I have here is, we'll get, so, okay, so there's where we set all that up. We got our file descriptor, and then this we're just going to use all this stuff. I'll just kind of walk you through why we chose these decisions. I know it's kind of a lot of code at once. So first thing we want to do, whenever we do a memory map file, it kind of comes back to this like mmap function that we're going to use. We've used mmap before. So we used mmap right here, right? So this is like a Unix kind of thing. There's a number of different things that we can pass to mmap. Let me see, I think I've got my mmap. Yeah, okay, mmap 2, the version that takes 2. So mmap, remember, so it takes address, the size that we want to allocate, the protection, then the flags. Okay, pages starting address. So we used mmap earlier in order to define kind of like a base address for where we wanted our memory to be, because for this game memory block, we wanted it to have a certain kind of base address. So we wanted to have a known base address, at least in our internally facing builds, so that we could do this kind of hot swapping the code out kind of feature. So we had to use mmap because you really can't get that sort of like finer grain level of granularity if you just did like a malloc. Okay, and so we pass it our base address, and we got this permanent storage size. So we're going to be allocating say 64 megabytes. But kind of the difference here is that there's a number of different ways. So you can do mmap and just get some virtual memory. But then another kind of possible option that you can do with mmap is you can have a memory mapped file, right? And we actually didn't do that for the game's memory, for some good reasons. But for the purpose of doing this kind of replay feature, it's actually kind of nice to have a memory map file, because then when you start the game back up, you'll actually be able to save all of your previous replay buffers, or you'll be able to like reload those. So it's nice to have the memory mapped to a specific file if that's the kind of thing that you need. And so all that we're doing is we're using this same mmap function to map to a file, right? And so that's really the only difference here. In order to do that, we have to pass it what's called a file descriptor. So I think at the very end, so this parameter, you see this int fd. Okay, so this file descriptor is kind of like a Unix thing. This file descriptor, you notice that here we pass -1 and -1 when we're allocating just the game memory block. And the reason we do that is because passing -1 there means we don't want to pass a file descriptor. Like, we're not doing that at all. So that's kind of how that goes, right? So, but if we did want to pass it a file descriptor, then we actually need to have the system create one. And so this kind of gets into what we're doing for memory mapped file. So we need to set up a file descriptor. These are just things that we need to do in order to open a file. So these are all just kind of basic things. First of all, this mode is like, what are the what SIRUSR, SIWUSR, all that means. You can look it up. Actually, maybe I have that right here, and I think I have like stat open up or something. Yeah, so so read permission owner, write permission owner. Those are just the permissions in Unix for that file. We want the game or the process to be able to read and write. And then we just, we're doing the same thing that we've done here for making a file name that's based on our path. So we're making a file name, and it's just going to be content/resources/replay buffer. So as soon as this program starts up, or as soon as this process starts up, the first thing it's going to do is it's going to make this file. And that file is actually going to be located inside of the bundle directory itself. So then it's going to build this, this file name path, right? which we've done before. We've used this function a number of times in order to build a file name inside of the bundle itself. And then we're going to get our file descriptor using this open function. So all this does is it opens a file. I think it's a little bit different from fopen because what is it? I don't think we have that necessarily. But open gives us a file descriptor. I think that if you wanted to then do fopen, you would have to pass that file descriptor in. But we pass the file name, and then all this does is this is like o_create. What it does is it just will open that. It'll create the file if it doesn't exist, but if it does exist, then it will just open it. Which over several courses of using the game again and again, that file will exist. ORDWR, I forget what that actually means. Let's look at like open. So BSD open function. Open. I think this is open 2 or maybe open 3. I forget. Yeah. Okay. So returns a file descriptor. Right. These are the flags. So I think the flags ORDWR. So open for reading and writing, which makes sense, right? Because we want to read and write. Sort of we want to read and write the contents of this sort of replay buffer file. So that's going to be really important. And then this is just passing this mode of kind of the permissions mode that we set up here. So writing and reading for user level access, right? Pretty simple. So we got the file descriptor, and then what we're going to do now, this truncate, I forget exactly why we do that again. Let's look into that, because then we'll sort of table that discussion for now. But so we do a truncate. Can't remember exactly why, but then we set up the memory block using the same mmap file. Don't care what the base address is for it, so we pass 0. That's unlike using mmap for the game memory itself. We want to only allocate the permanent storage size. Again, this is up to you if you want to use permanent storage size plus transient storage size. I just wanted to do the permanent storage size. It's a little easier. Same protections, read and write protections, not really much of anything different from what we use in the other ones. Private to the process itself, makes sense. And see, here's the key difference. We're using a file descriptor here, the same file descriptor that we got from open, right? In order to map that memory. And so what that's going to do is that is how you do memory mapped file I/O in Unix. Is you pass it this file descriptor, right? And then now you've got it kind of like the memory is mapped to that particular file, and so it'll load the contents of that file, etc. I'm not entirely sure all the other stuff that kind of goes under the hood when you use the memory map file, but this is how you map memory to a specific file on your system. So it's kind of cool. And then, so this gives us our memory, this gives us our replay block, and then our replay file handle, all we do is we just fopen that file name, and then we give it the R+. I think we've used that before, this R+, let's see, I want to say, yeah, we use this when we read a file. Yeah, we use that when we read a file. I think it's like there's like a little bit of extra permissions. I gotta remember exactly what that is. In any case, we give ourselves a file handle to load the replay. So that's going to give us a pointer to the start of that file, which is actually in memory now. And so you imagine that we've allocated something that is roughly the size of, it's like 64 megabytes, and it's memory mapped, and now we have a pointer to the start of it. So or a file handle that we can then use just like any other file handle. We can write to it, we can seek around it, and you'll see how we're going to be able to do that. What we're actually going to do is we're going to skip. We're going to reserve the beginning of that file for the game's memory block. And then what we're going to do is we're going to skip over that, all the 64 megabytes, and then we'll start recording inputs into that file buffer. And then once we're done recording, we'll just stop. And when we loop over it, all we do is we just go back to the beginning of the file. So it's a lot of kind of skipping around this particular file handle, but gets to be pretty useful. So, and you'll even see this kind of the first thing that we do after we make the replay file handle is we seek over the permanent storage size. So over 64 megabytes, right? Which we can look at. So first thing I want to look at is this truncate function. I kind of don't really remember what truncate does. Truncate units. Let's see if I get that. Truncate 2. Shrink or extend the size of a file to a specified size. Okay, so I think I get what we're doing there with the truncate. Basically what we're doing is we're saying just make that file at least the size of the permanent storage size, right? So we want, at the very least when we make this file, we want it to be those 64 megabytes, just to start off with. So, and I think, yeah, if for some reason we can't, then, I don't know, like the game crash, we really need that to happen. So, that would mean that, like, there's not enough space on the disk or something to be able to do that, I'm guessing, right? And so then, presumably, you wouldn't be, like, skipping around it would probably cause a crash or something. But we probably wouldn't expect that to happen on our development machine, so we're sort of not taking it super seriously at the moment. But you could log it if you wanted to. I don't know if that's something you want to do. So, and then fseek, again, let's look at that function. It's kind of another Unix thing. Right. So let's see. Fseek sets the file position indicator. I really wish that this documentation would see, I don't like this because oh no, wait, here it is. Okay, yeah. So this is our file star pointer. How much of an offset do we want to have on it? So what we're doing is we're saying yeah, so here's our file handle, and then we want to skip over 64 megabytes. And then I'm not sure exactly, I don't remember what seek set means. I think they'll tell you. Okay, the whence argument to fseek was not seek set or seek end or seek cur, would be negative. Yeah, but what is, okay, with whence? Alternate fteln seek with whence set to seek set. Setting this and storing the current into and from the object referenced by the I don't remember what seek set is. To obtain the current value of the file position indicator, rewind. If whence is set to seek set, seek cur, or seek end, the offset is relative to the start of the file. Okay. Current position indicator or end of file, respectively. Oh, okay. So with seek set, what we're saying is start at the beginning of the file, basically. So that's kind of what this whence parameter is all about. So we want to start at the beginning of the file, right? And what we're going to do is we're going to skip over this permanent storage size. And the reason that we're doing that is because we want the beginning of the memory of the file to represent the game memory at the moment when we took the snapshot, or at the moment when we started doing live loop editing. And then what we want to do is we would want to skip over that to the part where we actually start doing the recording itself. So that's kind of the structure of this file, basically. Like the beginning of it is the memory block that was saved when we started, and then the end of it is is all of the inputs that were taken from the controller, right? And so that's kind of like just sort of what that file looks like. So there you go. We've kind of set this thing up. We've got we've got all of these. We've got this kind of like memory map file kind of going. So the next thing to do is kind of right before update and render. What we want to do is we want to say, okay, well, if we're recording, right? So if max state dot is recording, right? Then we want to actually like take the input and record it, right? But also, if we happen to be playing back, then what we want to do is we would want to just run, instead of taking input from the controller, right, and passing that into game update and render, we would just be passing input from this file, from this memory map file, right? So that's kind of the idea, and then just kind of going all the way up into the end. So and again, I've got a lot of this stuff kind of already done. So gosh, I have a lot of this. All right. Yeah. So, and that means we need these two functions, right? We need Mac record input and Mac playback input. So it becomes pretty clear that these are important, and we're going to kind of talk about some of that, right? So Mac record input, Mac playback input. I like to put those just in order to avoid kind of compiler getting confused about where stuff is. I like to do that kind of right before this, right before the keyboard controller code, so right here. So this is kind of where we're going to start having all of that. And I'll just copy what I had already, just so we don't take too much time here. So there's kind of what we're going to be doing. So we've got kind of all these stubs of these functions, and we're going to kind of go through all of that. Because there's kind of a lot going on here, but so first of all, there's a few things that we're going to want to be doing. We want to have kind of a clear point at which we begin to record input from the controller, and when we're actually saving into this file. And we also want to kind of have like a clear point where we stop recording input from this thing. And so that's kind of what begin recording and begin recording the input and playing back the input. I sort of feel like it's kind of more important when going over this. It's probably better to start with beginning the recording, just so you see. And so where we want to do that, right? So let's start with this. So we know that kind of in the game's update loop. I just want to finish my previous thought. So we know here that right before we do update and render, if we're recording, we want to record it, right? And what this means, we'll talk about that kind of in a second. And also what this means if we're playing back, we'll kind of talk about that. But I sort of think it's going to be useful to like set that up a little bit so we understand kind of the state that we want the program to be in when we start recording input, and also the state that we want the program to be in when we start playing it back. So that's going to be a pretty important thing. So let's talk about that a little bit. So first thing first, where are we going to call that? And what I'm thinking is, and also kind of what Casey thinks, is we do this in the keyboard. So what we want to do is we want to pass a pointer to this max state into the keyboard. So whenever we get a keyboard event, we're actually going to pass max state. So we mac handle keyboard event, and then we'll just pass max state. So we got that. And I think if we do this like on the L key, that would make sense. So just whenever the L key is pressed down, and I think for, Casey uses it as like live loop or whatever. So, that's just kind of something to consider. So here's the idea. If it's not recording, then we want to start recording, right? And the function that we want to have there is that, what is it? So begin recording, Mac record, no, not record input, but begin recording input. Begin recording. Oh, do we have that? Playback input, end input, begin input playback. I'm not sure I brought that over. Okay, here it is. Yeah, begin recording input. Okay. So, whoops. All right. So what's the state that we kind of want this to be in when we start to record input? And I'm just going to go back here. Oh, oops. L key code. Right. So we're just going to pass that the max state pointer, right? So if we're not recording yet, we want to begin recording, right? So what does that mean? Well, here's kind of our little safety. So if we've got this memory, replay memory block, that's just our that's just like where we just set that up, really. That's our memory map file for the replay. So the first thing is the recording handle is just going to be the same as this replay file handle. So we're just setting the recording handle. And this fseek again, remember. So we're starting at the beginning of the file. So we're going to start at the recording handle, beginning of it. And we're going to seek up to the permanent storage size, so 64 megabytes. So we're seeking past that part that is we're seeking past the part that's the game memory block. And then we're going to do, so this mem copy, let's look at that. So mem copy. We used this before. What I believe this does is it's going to, okay, mem copy. So void star destination, void star source, okay, source dest size, right? So it's just a simple copy. So we're actually copying, is it the destination first? Yeah, it's destination first. So destination is going to be this replay memory block, which again is this memory map file. So that replay memory block, it's actually going to be, we're actually copying the game memory to the start of that file or the start of that memory block. What we're doing with this mem copy is, this is that snapshot I was talking to you about. This is that taking a snapshot of the game's memory at the moment that you start doing live loop editing, right? what we're going to do is we're going to save that into this memory map file. So we have the kind of the state of what the entire game was at the beginning of when we started recording, right? So that's kind of what this is. We're just copying that full game memory block over there, that pointer. So remember, this game memory block is just a pointer to the game memory that we allocated up front. So whatever that memory is, right? We're just gonna copy it to the start of this buffer, and we've already seeked past that in terms of file I/O. We've already seeked past it. So now, when we're about to receive input while recording, what we're going to be doing is we're now going to be appending these new values from the controller past where that file is. So that's just to kind of give you a sense of what we're doing. And then kind of the last thing we do is we just say, okay, well, now we understand that the state is us recording, right? So we're recording input, we're not playing it back, right? Okay. So now we know kind of what we're doing when we begin recording our input, right? And that's pretty useful. That sort of sets us up to kind of talk about what happens when we do this Mac record input. So remember that Mac record input, if we're recording, then we're going to be passing in pointer to this Mac state and the new input on every frame. Okay, so every frame, what we're going to do is we're going to take this game input, and now we're gonna write it to the recording handle. So let's kind of go over sort of what all of this means all the parameters in this fwrite function. So that's another Unix. So fwrite. Okay, so I'm guessing. Okay, yeah. So pointer to the fwrite. Yeah, so the function fwrite writes n member elements of data. So that's this thing right here, n member. So how many members are we going to do? Well, we're going to do we're actually going to write an entire snapshot of the whole input from the controller. And the size, each size, so each the size of a char star, so each like the size of a byte. So a byte is kind of the granularity that we're looking at for doing a write into this, pointed to by the stream. Again, so that's the recording handle, and obtaining them from the location given by pointer. So pointer just being this thing right here, which is a pointer to new input. So what it's doing is it's taking the data from the controller input and writing it at the granularity of a single character or a byte, and writing all of the entire size of. So remember, star new input, we're dereferencing new input. So that means that we're actually getting the full chunk of memory that represents the entire game input. So like that really is it's saving like a full snapshot of all of the controller button state for that particular frame, and it's going to write it at the granularity of a byte, or a character, right? And then we're going to and it's using this recording handle. So basically, that recording handle, the pointer for that is going to advance by the amount of an entire input each frame as this gets written into memory. So remember, this is a memory mapped file, so it's actually getting written into memory, but then it's got this file kind of backing it, so that when we restart the game, we'll actually have that saved, and we could just like load it if we wanted to. So and then if we didn't write any data, that would be really strange, because we should, and that would be a problem, right, if we couldn't. So that's kind of what's happening every time we record our input. And then now when we play back our input, it's just going to kind of be the opposite of that. So it looks very similar, right? So what we've got, it's gonna read those, it's gonna read data, the size with the granularity of a single character, and it's gonna take all of a single input, and using this playback handle, and then it's gonna read it into this new input variable, so that by the time so remember, this gets called in the run loop, and so we hit upon this when we're playing back, and then then now new input is going to have the data that was taken from that playback handle, and new input is then going to be fed into game update and render, which is basically going to be, it's going to take that as if it came straight from the controller, right? Game update and render doesn't make a distinction about what the controller is or not. It just knows that it needs an input, and so it's going to take it from the file instead of directly from the controller. So even though we still have all this code up here that loops over all the controllers or whatever, and figures out how to set things, it doesn't matter, because that just gets straight up overwritten by by this playback thing right here, right? Okay, so that's hopefully gets you a sense of what's going on here, and why some of that works, or what we're doing here. So we're simply reading out what comes from that file. Now there's a little bit of setup too when we play back something after we've recorded it. So let's kind of go over the whole loop of what's going to happen. I feel like that's going to be really important. Then I'll kind of tweak the code a little bit, or just show you kind of how things get set up. We're kind of coming up on an hour or so, so I'm actually pretty happy with kind of how much time this is taking, but let's just kind of go over the whole thing. All right, so when I'm doing this, what I'm going to do is the game's going to be running. We've already set up this memory map file. I'm going to hit the L key, right? And the first time through, what's going to happen is we're going to set up the recording handle, and we're going to start at the beginning. We're going to skip past the size of the memory block. Then what we're going to do is we're going to copy the game's memory to the start of this memory mapped file. So we take a snapshot of the game's memory at the moment that we press L, right? And then we're going to say, okay, now we're recording. While it's recording, it's going to be writing each new input on each frame to this recording handle, and it's going to keep advancing it. So we're writing snapshots of what's coming from the game controller each frame. Okay. Then once we decide that we're finished recording our input, we're just going to set this little flag saying, okay, we're no longer recording, right? Just to kind of let the system know, and we have logic in here that handles, or that knows what to do kind of when we've finished recording, right? Now I haven't actually covered when we're going to call begin input playback, but input playback is basically like the reverse of this. So again, we're saying, okay, so the playback handle is basically just the replay file handle. And this logic might be more simplified. Maybe we don't even really need a playback handle or a recording handle. I think I took this from the more advanced version. I just kind of tried to boil it down to the simple things. So through your own experimentation, I think you'll probably find something that's a little bit maybe better. And again, what we're doing is we're seeking over the permanent storage size, because we don't want to be reading inputs from we don't want to take the game memory and read that as if it's an input, because that's going to be totally wrong. And remember, C is not really a memory safe kind of language. If you say that this memory is a dog, it's a dog. It's whatever it is that you say it is. So We have to be a little bit careful about, making sure we like skip over the game memory block. And then again, what we're doing now is, now remember, memcopy starts the destination, so the destination is the game memory block. So we've got this pointer to the game memory block. What we're doing is we're copying the memory from the replay memory, which is what we saved earlier here, right? So now we're copying our snapshot that we saved at the beginning of the recording, and we're putting it, and we're saying that's the game memory block. So we've just swapped it out. We swapped out the game's memory for what it was when we started recording. Okay, so we saved that snapshot at the start of the recording, and now we're swapping it back, right? And then we're saying, okay, well now we're playing back. So we're just setting this little flag to say, hey, we're playing back, just so you know. So as we're playing back, then what we're going to be doing is we're going to be reading the inputs from the file instead of from the controller. I just went over that earlier. This happens on every frame, and this is a little bit different because eventually we're going to hit the end of those inputs, right? Like there's no infinity amount. Like you only recorded for so long, right? So you're going to record kind of like what you're doing on the controller for a certain period of time. And then eventually you're going to hit L, right, again. So if you hit L a second time, then we're going to stop recording and we're going to start playing it back. Well, as it's playing back, it's a little bit of a decision as to what you want to do with your engine. But as it's playing back, we actually want... There's going to be a point where we've reached the end of the file, right? Where there's no more inputs to read. And so what this is saying is if the byte's read, because every time you call fread, it's going to give you an unsigned 64-bit integer telling you how many bytes were read. And if there was like less than 0 bytes read, well, or 0 bytes read, well, then that means you've reached the end of the file, right? And so that means you probably want to do something. In this case, ending playback and then just beginning playback. So that's kind of why we have these end input playback and begin input playback. So end input playback right here, and then begin. So all it does is just loops back over again. And so this is kind of nice because when you have a loop going, this behavior is nice just because you record some loop of play, right? And then what you're actually going to be doing is while you're watching this loop of play go over and over again, remember, we have the ability to edit the source code of the game while it's running in looped mode. So you say, oh, okay, well, this loop is playing over it. I don't like the size of that jump. I don't like how that looks. I don't like, this boss is like got a stupid color or whatever. He looks kind of dumb. You could just change the code and then like watch the loop play over and over again as it goes over your new logic. So these are all pretty darn impressive things to be doing, which again, you only really get when you have this low of a level of access to memory itself. So we're kind of talking in the language of C, which is really at this lower level of memory, and it allows us to do some pretty cool things. So now that we've got this, I want to go back to so L key code, right? Okay, so we've got this. What I want to do is just you'll see. This is my final logic that I have. I'm just going to use that. This is what happens when we hit the L key. Okay, so if it is playing back, if it happens to be playing back, then we just want to end the playback. So if we're already like playing over the same loop again and again and again, we just want to finish that playback cycle, right? So that's kind of what this is. and then we just break from it. We don't want any of this other logic to run if we press it, because then it's like, oh, well, I don't want it to start recording or anything like that. I just want it to end. And now if it's not recording, we're going to start recording, okay? And otherwise, we're going to end recording. So if we hit L again, and it's if it is recording, then we're just going to end recording and we're going to start playing it back. So that's kind of what's going on. So first time through, this is how it's going to work. First pass through, if we hit the L key, we'll start recording our input, and then for whatever duration of time, and then the second time we hit the L key, we're going to just finish recording that input, and then we're going to play it back. We're going to start playing it back. And remember, playing it back is what starts the loop, because once it hits the end of that loop, it's just going to start at the very beginning again, over and over and over, until we hit the L key again, because it's playing back, in which case it'll just stop the playback. And so I found this to be kind of useful, because it's sort of like, as you're playing your game, you can kind of go through these different modes. So in the middle of a loop, you can say, oh, I want to stop right there. And then you hit L, and then you maybe play around, with the controller or whatever, move the character, whatever it is you want to do, and then start another loop, and then kind of, do whatever other thing that you want to do. So it's nice. It's I like this behavior. But again, this is your game engine. You can sort of customize it however you want. So that's kind of the cool thing about this. If you don't like this behavior, hey, it's yours. Completely free, open source thing for you to play with. So I'm just going to build and see. Okay, so we have this thing built. It's building, and again, I'm sort of cheating, because I am not as experienced as Casey, so I tend to run through these before I do a presentation. But it's good. So we got all right. So day 25, I got my. Okay, so now you see this, and again, we had done a few things. So now we know that. So this is moving. I'm pressing right on the controller. Okay, so now what I'm going to do is I'm going to hit L. And you heard that little kind of thing. And now I'm just pressing right. I'm not doing anything fancy, right? And now I'm going to hit L again. And now what it's doing is it is doing exactly what it said it would do. It's taking the start of when I hit L, that whole memory block, and it is saving it. And then what it's doing is it's playing over those inputs. It's playing over me hitting the right on my D-pad. And now once it's finished, it just stops the playback, and then it starts at the very beginning. It's not as instructive when you see it here, because in reality, when you're using this kind of as, I sort of feel like I've belabored the point quite a lot, but in an actual game, so this is the this kind of like platform game that I'm making. In an actual game, part of what I'm going to be doing is I'm going to have a character, right? And so now I'm going to hit L here, right? And my character is moving around, and it's actually playing back some important game input or something that I care about seeing. Like maybe I wanted to just see what it looks like to watch the player go through an entire level, right? And then because this is like live looped code editing, I can then start at the very beginning, etc. I can tweak this. I can tweak the source code. Maybe I draw a different character. Maybe I make the characters jump a lot stronger. Maybe I change, tweak the parameters on some kind of core mechanic. And then when I'm done playing with that, I can just hit L to stop right in the middle of playing back and kind of get me where my character was. And then maybe if I want to record here again, and I don't know, I'm going to go and look down at this part of the level or something, and then move my character back, again, and play that back and sort of see kind of where I am and what I want to do, and so I'm happy with all of this stuff, and then finally, okay, I don't want to play back anymore, etc. So it's nice. It's something that when you don't actually have the game engine drawing a character like this is. My character is just a square, right? It'll be a character once I kind of stub out more of the actual gameplay, or figure out what the heck this game actually is, or what kind of game mechanics I want to put in there, or I'm basically using this as a testing ground for different ideas that I have, and later on I'm gonna make it into more of a fully fledged thing, or once I understand what this game's about, then I feel like there's more of an art direction, or all of those other kinds of things that one would think about later. But I want to kind of get the gameplay in first. So these are the kinds of things that you can do when you have it kind of set up this way. It's pretty cool. So, gosh, at this point, I sort of want to stop and declare victory. There's maybe a little bit more kind of cleanup on the platform layer that you can decide to do if you want to, but I actually don't think that there's much. I don't think that there's more that's really needed here. You've got pretty much everything that you need in order to continue to follow along with the series. This puts you at day 25, roughly. Lines you up with Casey's series. So that's freaking awesome. I mean, you'll be able to follow along pretty far into it. Like I said, I'm at day 51 right now, and I'm just kind of following along in my spare time. But I'm also just kind of watching a lot of the other lectures. I'm at a point where I'm just skipping around. And I'm skipping around because I want to kind of make my own game as well. So this gets you to that place where now it's kind of up to you. So I feel like it's really cool, probably following along to the first 50 days. I like that because Casey sets up a lot of he kind of stubs in a lot of the gameplay and a lot of the really important things, like the collision, a first pass in the collision detector, I think is a really cool and valuable thing to see. And so there's a lot of things. There's a lot of things about setting up a tile map, setting up a world, coordinate systems. I think that those first 50 days are really, really foundational. And then I feel like I could be wrong. Maybe a year from now I'll say those first 100 days or those first 200 days are really foundational, or maybe I'll say, you should just follow the whole series. I'm not really sure, but for me, I don't know. Right around day 50, I kind of started itching to make my own game, and you may feel something similar, but you have the ability now to follow along on a Mac, and I happen to be building my prototyping my game on my Mac. I don't really care because I feel like if I have something and I need to port it to another platform, I'll just start doing that. And I kind of see no problem with it. To me, it's kind of cool to just have it working on a Mac. But yeah, if you want to do that, I feel like I have, at this point, a year later, sort of accomplished what I set out to accomplish, which was giving people a nice ramp up from the very start so they could follow the series on a Mac. And I feel like if you actually get to day 50 or day 100 or much further in the series, your chops at writing C code, your ability to program in this way, in this kind of procedural lower level style, it'll go up. If you actually put in the time to follow the series with your own platform layer, eventually you're going to you'll get to a point where you don't really need a video series to start kind of thinking the way that you would want to think in order to put these things together. So I would say that kind of the usefulness of something like this sort of starts to go down, because eventually if you have the willingness to just follow the series, and the willingness to put in the work, you'll just become the sort of person that doesn't really need a video series to follow. So, this was kind of geared at people who are like just starting out. But gosh, if you follow this for 25 days, like, props to you, because chances are you'll go pretty far. So in any case, I appreciate the time that you put in learning how to do this, and it's been fun for me. And go out there, make a cool game. Let me know how it went, and I'll make a few videos here and there. I actually kind of want to do, because I moved my whole game over to Metal as the renderer, and I thought that was pretty cool. And it was especially nice because, like, seeing things running at 60 frames, like, I ain't going back to like 30 frames. Like, 30 frames sucks. Like, there's no way I would run a game at 30 frames anymore. So I feel like getting the GPU going, it was ridiculous. It was something like, to render a single frame of my game would take, like, I don't know, like 15 milliseconds or something stupid, like just like a ridiculously long period of time. But like, I was profiling the GPU, and it was like, and granted, I'm not having it draw a ton, but it's like drawing my frames at like 64 microseconds, which is insane. So to hit 60 frames a second is actually a lot easier once you move it over the GPU, and there's so many other cool things it'll do. So I sort of feel like it won't when I do it, I won't exactly be following the series, but it'll be maybe just like a little video series on kind of how to convert the renderer, how to start rendering some of this stuff in Metal. That'll be kind of useful, I think. But I sort of want to take a break from this project and kind of move on to some other things. So that's kind of the plan, at least in the short term. Unless somebody, like, I don't know, donates like $500, then I'll do it. Then I'll do it. But for now, I think I'm going to happily wrap up this project and say mission accomplished. And if you have any questions, let me know. If you want to support me on Patreon. Obviously, support Casey as well. Handmade Hero, for me, has been kind of life-changing in a lot of ways. It's really changed the way that I look at programming, and for that, I am endlessly appreciative. So with that, I will say later.